Okay, we are going to have an attempt at question 45 from the Stage 1 physics textbook. So this is a question on ohmic circuits. The diagram below shows a conventional current flowing through an electric circuit. The circuit has been identified in three locations. The current has been identified in three locations in the circuit. The resistance of two resistors is provided. So we got two resistors. We've got the 4 ohm over here, and we've got the 2 ohm over here identified, and we've got current, and we also have current down here. Now, so we've got a region of series, so this resistor and this group of resistors and the final 2 ohm resistor are in series, but this group of resistors, the 4 ohm and resistor 2, are in parallel in this section. So we have two things going on here. All right, show the potential difference across the 4 ohm resistor is 6 volts. All right, so we've got, you notice here, 4 ohms, and we've got 1.5 amperes of current going through this section. Note that actually pretty much automatically says, let me find my pen, okay. All right, this section here would be, oopsies. All right, so that point here. Sorry, my trackpad's not working. All right, so I'm just going to write it here under here. You got 0.5 amperes. All right, because if let's go in that way. All right, so we've got 2 ohms, 2 amperes there and 2 amperes there. Well, 2 amperes is feeding in, 2 amperes is coming out. That's correct in series. And then you have 1.5 here, then this must be 0.5 ampere of current going through that one. All right, so the makeup for the 2. All right, but let's just get this potential difference done. So we're solving for, we don't know what. All right, so we don't know V. Alright, so we want to know upstairs. Alright, so solving for V equals okay, I R, alright, equals, alright, current is 1.5 times 4 ohms, okay, which is 6 volts. Oops. Alright. Alright. So that's easy enough. Alright, so we've got to show the 12, the resistor 2 is 12. Alright, so we've got to solve for this resistor here. Okay, so see that. Now we know that's 0.5 amperes. What we also know that if this is 6 volts, then this is also 6 volts. So when voltage comes through, it in parallel, the voltage doesn't decrease. It gets it's the same in both. Okay, so we can actually use these two to solve for that. So, all right, a bit of space. So again, V equals I R, and then okay, R equals V on I equals, so what have we got again? We've got 6 volts and 0.5 amperes. All right. 6 volts over
0.5 equals 12 ohms. I'm starting to get the hang of this. All right. So that's part B. All right. So what's part C? Calculate resistance of resistor 1. All right. So resistor 1. Now let's have a look. I'm not able to see all of this. 3 marks for this one. All right. So approaches to this. We know that there is a total of 12 volts going on. That's what's providing the potential difference, is the 12 volts here. And the current running through the circuit in the main path, the main series path, is 2 amperes. Okay, so we can actually work out the total resistance and then work out what resistor 1 is from that. So the total impedance of the circuit, let's work out that. All right. V equals I R. R equals V on I equals. All right. So we've got 12 volts. 12 volts over 2 amperes equals 6 ohms. All right. So we've got 2 ohms over here. All right. So we've got the resistors we know. We've got R1 is unknown. Oops. Let's made a mess of that. That one's unknown. R2 we do know, but that is in parallel. And then we've got, okay, with that we have a parallel. We've got 12 and 4. Okay, we can reduce that in a minute. And we've got the other one is, all right, the other one we know, that's 2 amp, that's not 2 amperes, 2 ohms. Okay, 2 ohms, all right. So we really have to reduce the parallel ones, and then we can pretty much work it out from the total resistance. Okay, so let's go find a bit of space. All right, so let's go make this. All right. All right, so to reduce that group, so we're going to go back and we're going to work out the total impedance of this section here. So we're going to do that, and then we'll be able to work out everything else. All right, so the total resistance. Okay, so you write we got 1 on 12 plus 1/4 and inverse of that. All right, so a quarter can be represented as 3/12, so we've actually got the total is 4/12. And take the reciprocal of that. 4 over 12 is 1 over 3. And reciprocal of that is 12 over 4, which is 3. Let's find where that is. 3. Okay, 3 ohms. All right, so think of it this way. We know the total impedance for this circuit is 6. So if it was one resistor, you would just have a 6 ohm resistor. All right, we've got 2 ohms here, and we've got this total section is 3 ohms. So 2 ohms and 3 ohms must make 6 ohms. So the 1 ohm that's missing. So let's just do this here. All right. So, okay, R1 equals 6 ohms, that's the total, minus 3 ohms, which is what we just worked out with the group of the two parallels, and also minus the 2 ohm resistor that's there. So then that is 1 ohm. There we go. 1 whole ohm. Alright. I'm practicing with my new stylus. Okay, so that is, I think that's all of it. Okay. Maybe just a bit of fun with this now, so we got this all figured out. So that was 1 whole ohm. Okay. So we can actually watch how this divides out. So this whole section has the parallels here. They got 6 volts going through them. I believe that'll be the total 6 volts. Okay, this part would have 2 times 2 is 4 volts. And then, okay, 2 times 1 is 2 volts. So there's 2 volts going through that series part. 6 volts going through the parallels and 4 volts going through the final resistor here at the end, so that one there. Okay, and 2 and 4 and 6 make 12. Alright, that all seems to work out. So that is the end of that.